Okay, let's look at a second example of trigonometric substitution. Let's say we want to integrate 1 over the square root of 1 plus x squared dx. And this integral is totally thinking, oh man, if I were the integral of 1 over the square root of 1 minus x squared, I'd totally be arc sine. And if I were integral of 1 over 1 plus x squared, I'd totally be arc tangent. But I'm not. You're looking at that, you think, well, I see 1 plus x squared. That makes me think of tangent squared plus 1 equaling secant squared. So let's try this trigonometric substitution. And remember, this is always gives you, it's a long, tedious thing. Always look for u substitution. Always look, if u was 1 plus x squared, you'd need that x dx. If there was an x up top, this would be so much easier. No, we have to do trigonometric substitution, and we're going to try to turn this x into a tangent of theta. And if x is tangent of theta, then dx is the derivative of this, secant squared d theta. Secant squared theta d theta. So the integral that we have, integral of 1 over square root of 1 plus x squared dx, becomes integral of 1 over the square root of 1 plus tangent squared tangent squared of theta, and the dx becomes secant squared of theta d theta. And the 1 plus tangent squared of theta becomes secant squared of theta, and the secant squared stays alone. So 1 over the square root of secant squared is just 1 over secant, and then 1 secant cancels out with one of these secants, and you are left with just the integral of secant, which I said before was one of the most evil integrals of all. At this point now, it is not the most evil. We have such more terrible things, but you could go through all of that tedious process, or you could just say, oh man, isn't that the, I don't know, natural log of secant of theta plus tangent of theta plus c, and you're like, yes, totally, exactly right. But we now want to bring it back into x's. Well, x is tangent of theta, so this tangent of theta turns into x, but we have to figure out what secant of theta is. That's going to require a triangle. So if x is tangent of theta, that means that theta is the sort of thing that goes into a tangent. It's an angle. So we have a right triangle with an angle of theta. We think, that triangle has to have a tangent of theta. How about, I don't know, it has to have a tangent of theta that is x. How about opposite over adjacent are x and 1? Using the Pythagorean theorem, 1 squared plus x squared is this thing squared, so the hypotenuse is square root of 1 plus x squared. The secant that we want is 1 over cosine. Cosine is 1 over this, so it's this over 1. Secant is very simply just the square root of 1 plus x squared. And so we end up with the integral that we wanted is the natural log of the absolute value of square root of 1 plus x squared, and then tangent was just x. Bang. The integral of 1 over the square root of 1 plus x squared dx is the natural log of the absolute value square root of 1 plus x squared plus x plus c. And yes, if you take the derivative of that, you get 1 over that thing times its derivative, whole lot of algebra later, and it will simplify to just 1 over square root of 1 plus x squared, and I actually don't feel like doing that at this moment.